So let's have a look at our manual. You already have this manual in Blackboard and with the name of a strength of material manual. So a strength of materials, it has a detailed explanation of all experiments, 16 experiments, plus an information about the setup itself. So we will have our main setup, and these components will fix specific experiments. So if we need experiment number 1, we will fix components related to experiment number 1. So if we come down to the contents, we will have an introduction, safety, for example, information for safety, about the system, about the hardware and software, and the gauging and calibrations, everything until chapter or unit 9, hands-on experiment, and this will be our experiment. So we have 9.1, experiment number 1, determination of modulus of elasticity and force distribution. Experiment number 2, 3, 4, we will have our 16 experiments. But before going to experiment number 1, we have very important table. It shows, in this figure we have our almost all of our components that used to perform the experiment. So in the procedures, when we perform our experiment, we are referring to some numbers. Let's have a look at this table. This is a strength of material laboratory component. So for example, when we say number 1, we are referring to the support, name support, and this is the figure shows the support, photo shows the support. Element number 2 will be support with lever, and this is the photo. Element number 3 for bins, clamps, fixed support, pole. So when we refer, for example, to number 12, then you should know, as a student, you should know that this is a movable pattern for square section, and this is the photo, because you will select it from our, you can see shelves of all elements, and then you can select the specific element 1, 2, 3, and fix them through the experiment. Good. Another table will be the table of specimens itself. So all of these was components. Now let us have our test pieces, specimens, in which we have the connections, because sensors will give data and then you need to transfer those data to the computer. So now number 1 is the specimen number 1, bilateral spin flat test piece. So not to confuse with number 1 of the components that we have seen before 1 minute. So this is number 1 for specimens, number 2 for specimens. So if we go, for example, to page 70 to perform our first experiment, you see in the manual we have in general some introduction, and we'll explain this in our lecture time. So, but in general, this is an example of how it comes, or objectives, the experimental determination of modulus of elasticity force ratio. This shows an introduction. What is the relation between strain and stress? This is modulus of elasticity. In terms of data, you will have 1, 2, 3, more, maybe 5 or 6 points measuring the elongations by sensor and measuring forces by the force sensor. And then you will generate your curve, and from the slope you will be able to calculate the value of E, modulus of elasticity. So we will cover all theoretical aspects in our lecture, calculations, but now let's perform the experiment step by step. So this is the specimen that we are using, specimen number 1. From that table in the introduction section, you will be able to recognize which specimen to select. This is the specifications, properties of our specimen, and the equations needed. So to prepare and conduct the experiment, we have step-by-step instructions. So we need to install the support number 1. Support number 1, from the table it shows that element. This is step support number 1, and we should fix it in holes number 10 and 11, so we can count from right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. We should fix the support number 1 with 10 mm bolts 1 and 2. Step number 2, install support with the lever. It has the number 2. So we go back to the table of elements and we select number 2 and we see that it is our element in here and fixed with the same bolt in holes number 1 and 2. Step number 3, the tension pins and the clamps. So we have one clamp with a pin, second clamp with a pin. Lastly, we should install our specimen number 1 itself in the gap between the 2 pins and we fix the specimen with another 2 pins. So our experiment now is ready. Now let's go and conduct our experiment. Step number 1, assemble this machine as described above. So let's go to the hardware setup and prepare our machine following the steps in here. So when it comes to conducting the experiment, we will start through the steps available in the manual. So assembling the test machine, the experiment is carried out in the tensile machine, this machine you have. Step number 1, install the support which has the indication number of 1. If you go to the table of elements, you find that the number 1 is the support. There is no need for this because they have it already in the manual. So install the support number 1. You will find out that this is the support number 1, and there is specific details. We need to install the support number 1 in the holes number 10 and 11 of the platform. So counting from the right, 1 2 3 4 5 6 7 8 9 10 and 11. So we should fix this support in this side, and we have the screws for one in number 11 and another one in number 10. Good. So this is step number 1. Perfect. So for step number 2, install the support with lever. It has the number of 2 in holes number 1 and 2. So if you go back to the table, you will find out that this is support with lever number 2, and we should fix them in holes number 1 and 2. That means in here 1 and 2. So this is hole number 1. Maybe this is the wrong one. That's good. Good. And this is hole number 2. Perfect. Good. Step number 3, we need to insert the retention pins number 3. Same thing, go back to the table of materials. You will find that pins number 3 are those pins, and we need them to fix the test piece clamps number 4. So you have this is the clamps and this is the pins. So we should fix them in here. This is pin number 1 and this is pin number 2. Perfect. Last step, we need to insert the specimen number 1. So as you know, we have two tables, table of materials and then other table of specimens. So this is specimen number 1, not to confuse with the element number 1, which is the support. So that was an element and this is a specimen. A specimen is anything it has sensors, and this cable for reading data through sensors. So this is the last thing. We will fix this element in here, and that's why we need other two pins, pin number 1 and pin number 2. So this will go in here with the pin and the other one it should go in here, but as you see we have some gap, and that's how we need to make less distance. And now we have the whole centric together, so good. So this will end our hardware setup, but remember that we are reading sensors, we are reading data through the sensors, and that's why we need to connect the sensor from the hardware setup to our computer. Starting with this element, we should connect this one, and this is all detailed in the steps in the manuals, so we should fix this into number 1. What is this? Yeah, this is reading the amount of force. So if you see here, if I make some screw drive, this is a screw drive, when I turn it on, there is tension in this specimen, because now I make some extension. If I turn it to the left, then this is loose. So this sensor will measure the amount of force that I'm applying in here. This is number 1. The other sensor is attached to the specimen itself. It will go to that connection to the computer. So this is our second connection, and it's perfect now. So for now, for example, if I apply some tension force, the sensor number 1 will measure the force itself in Newton, and the other sensor in here, it will measure the elongation in each small particle in this element, in the specimen itself. So basically the experiment is that we want to change the forces more than maybe 5 or 6 times. So we'll apply a specific force, and in the computer, as you know, we have the indication of force. So in the computer we can see the measure that, for example, 10 Newton, we will apply some force and we stop until we see the 10 Newton, and then we can measure the stresses, strains, elongations, and everything. Again, we will change another force to maybe to 20 Newton, and we will measure to read the data for the 20 Newton, and then again 30 Newton, and because of that we will have our curve of stresses, strains, and modulus of elasticity and everything. So let's go to the computer and finish our experiment. Good. So now we have done the first step in conducting the experiment. We assembled our test machine as described in the steps. So step number 2, we should loosen the specimen by turning the knob on the lever. So to make sure that no load is applied, and I showed you that by turning the lever to the right, we will apply some force. Now we start from the beginning, and we should make sure that there is no force applied in order to make sure that we are starting from no load case. Step number 3, we should run the Strength of Material Lab software by clicking the respective icon on the desktop. So if I come to the desktop, I will have the Strength of Material software. If I double click this, one second. Yes, this is our software. It has this steam experiment, and for now we will start with the first experiment, determination of modulus of elasticity. So double click this will open our software. Good. Let's go back to manual. So we did that. We run the experiment, the software, open the lab by double clicking the first one. So we already opened our first experiment. So the specimen parameters tab will become active. What is that? So this is experiment parameters. We know that specimen number 1, it has these information. Coefficient of sensor is 1, thickness is some value, width is some value, modulus of elasticity. Officially we know that material it has a specific modulus of elasticity, and force is a specific value. Good. So each time you can switch between the tabs during the experiment. What tabs? So we can go to table of readings, increments, and stresses. We can go to specimen and diagrams. Still we don't have anything in the graph. So officially, or from the beginning, we have only these properties. Good. Then each time you click measure button, a new line of the measured strain gauge data will be added. So in this table we have nothing right now, but if I move the knob to the right and I apply some force, like this for example, I'm applying, but before that I need to start. Yes, start. So if I apply some force, we will see that the gauge is reading some value, but this is not counted in the table yet because I didn't click measure. So this is how it works. Less force, less readings, and I say measure, specific value will come. Good. So you can choose state. Good. So now enter the specimen data into corresponding files. So I need to make sure that because I have more than one setup, I should make sure that the sample in machine right now it has the specific coefficient, because maybe you have more than 4 machines and 4 specimens and you have confusion between the details, but this is okay, I already checked that. Now, good. Now we should start. By clicking start the software, I already did. Taking the meter on the screen, apply force slowly. So I should apply by the force by taking the knob and deliver up to initial force of 100 kilogram force. Good. So going back to the software, this is only 25 for example, but he said that I need to have almost approximately 100. I can see that it's 95 now. And this is almost 100, and now I click, this is 7, I click measure, so this will be my first reading. That's good. So I have the force is 99.3. I have the sensor number 1, it has negative elongation, sensor number 2 negative elongation, and sensor number 3 positive elongation, and that's why, because these are lateral sensors and this is normal sensor. With longitude in the x-axis, longitude and axis, so this is, but this is middle size. So step number 2, click measure. I already did, and that's why, as you see in the manual, we have the data in the pedestal. Now we should apply an incremental force delta T equal to 25 and click measure each time. So we will go here, instead of 100, we will make it, I'm turning the knob to the right, and it will stop at 100 plus 25, the increment is 25, so this is good, 25, and then again click measure. This is our second measurement. Go back to the manual. So we need 5 readings to be registered in the table. So again, plus 25, I should have 150. Approximately 150. This will be enough. And to measure. And after that, plus 25 will be 175, approximately. This is enough, and measure, and last increment will be applying a force of 200 kilogram force. Yes, almost 200, and measure. So you will see that in our graph, a relation between load and increment, and up to now we are in the linear case, and then from this slope we can find the modulus of elasticity, and this is our result. You should do the calculations and then compare your result with the automatic result in the next video. So how we can save this data? We should go to menu and save. This result will be automatically recorded at my computer. If I go to my computer, see strength of material, you will see that in Excel we have this file generated by today. So this is 7th of June 12:13, experiment number 1, and this is our table, this is our properties, this is equations needed, and this is our results for calculations, in order to make sure that our results are similar to the one available in the results given. Just to show the graph, we will have the stress applied into this specific, and that this is our experiment. Thank you.